Well, we have a question here that says, given the finite geometric sequence 5, 1, -3, 83, -83, and 287. Now, question 2.1, I'm going to write here question 2.1. 2.1, we want to find T4. Okay, the question says write down the fourth term T4. Now, first, let's see what type of a pattern is this sequence. So we can see that if I look at there, we notice that 1 minus 5 is -4, and -3 minus 1 is also -4. Now, because we have a constant, and then over here also, if we do -87 minus 83, this is also -4. Now we notice that we do have here a constant ratio. Excuse me, a constant constant difference. I meant when we have a constant difference, then we know this is a arithmetic sequence. Okay, arithmetic sequence or arithmetic progression. So now we're going to add -4 from term 3 to find T4. So therefore, T4 will be equal to -3 plus minus 4. Okay, plus minus 4, which is just T4 will be equal to -7. Now we're going to see question 2.2. The question says, calculate the number of terms in this sequence. All right, because it is a finite sequence, finite because it has a final term. Okay, in the sequence, the pattern has a final term, which is -87, and then we need to find how many terms are from 5 to -87. So we can do that. Excuse me, by writing the formula of arithmetic sequences given Tn equal to A plus n minus 1 times D. Now we do know A, the first term, which is 5 plus n minus 1 times D, the constant difference, which is -4. Now if we work out this will make a 5 plus minus 4n plus 4, okay, because you do -4 times n, -4n, -4 times -1 makes +4. And now we will have like Tn equal to 5 plus 4 is 9. So and that makes actually -4n plus 9. So this is Tn. Now, because you know Tn, we can find the number of the term, okay, by substituting the last term, okay. So when I say the last term here is -87, to find the number of the term here, actually we are looking for n, okay. The value of n will determine the number of term. So I'm gonna write here -87 will be equal to -4n plus 9. So if I move the 9 over, that will make -87 minus 9 equal to -4n. And now -87 minus 9, this is equal to -96. Okay, that makes -96 is equal to. Okay, let me just move this a little bit here. That makes -96 equal to -4n, and then we divide both sides by -4 and -4. Then therefore n will be equal to 96 divided by 4 is just 24. So this is 24. N equal to 24. Therefore, the number of the term is 24. Now on a move, we're going to do question. That was question 2.1. we did question 2.1 and 2.2. Now we're going to do question 2.3. Well, the question says, calculate the sum of all the negative numbers in the sequence. Now we can see that the negative numbers are from -3 to -87. So the first two terms are not part of this calculation because they're positive, 5 and 1. So in other words, we only have left with 22 terms. So we're going to do the sum of 22 terms starting from -3. So this will be, I'll write it here. Uh, 2.3, we are basically asked to find S22. This is what we're looking for. And then starting from -3, so -3, -7, 83, -80, 83, and -87. Now, we do know that Sn is given by, for arithmetic sequence, is given by n/2, 2a plus n-1 times d. Okay, and then S22 will be then, you know, substitute the number of terms. Okay, I say, maybe let me just say it over again. Terms were like this. Now, you notice that 5 and 1 are the positive terms, but we want the sum of the negative terms. So now, because the total number of the terms is 24, we need to do the sum of the negative, so of the sum of 22 terms, these ones. Okay, so S22 will then be 22 there for n/2. Okay, we can also use the other formula because we know the first and the last term. Sn can also be written by, Sn can also be given by n/2 a plus L. Okay, we use these two formulas, but this one is specifically when we have finite sequence. Okay, so now I prefer to use the second formula. It's going to be quicker. So S22, in other words, S22 will be equal to n/2, the first term, excuse me, and the last term. So S22 will be 22. The first term is -3 here, and the last term is -87. So now we can use a calculator. S22 will be equal to, first my calculator over here, I'm going to say 22/2, okay, and then open bracket. The first term is -3, and the last term is plus minus, okay, because over here it was plus minus 87, which is just negative. So -87 here. And then we close the bracket, and then when we hit equal, we have like a -990. So this is -990. So this is the sum of the negative terms. And then this was question 2.3. Now we're going to do question 2.4. The question says, consider the sequence 5, 1, -3, 83, 83, 87, and then up to -4,187. Determine the number of terms in this sequence that will be exactly divisible by 5. All right. Well, we're going to do question 2.4 in the following video. So I'll leave it out like that. Thank you.